Okay, 3 by 3. This is what a 3 by 3. So you need x, y, and z. We need 3 equations to solve. So the key here is being organized. So looking up and down the x's, the y's, the z's, I'm going to decide to eliminate my x's first because they look very much alike. So what we're going to do is we're going to focus on eliminating these two x's from those two equations, and then we're going to focus on eliminating the x from those two equations. You have to involve everyone in the process. So what I'm going to do is if I work on the first two, to eliminate x, I'm going to need to multiply everyone by -3 in this bottom equation, so that I have a -3x plus 3y minus 3z equals a -12, and on top I still have 3x minus 2y plus 4z equals 15. That one did not change. So I can now linearly combine them. Those go away. 3 minus 2 is just y. 4 minus 3 is just z. So y plus z equals 3. Now, unlike a 2 by 2, that doesn't get you an answer right now. So I need another 2 by 2 that has y and z in it. So now I'm going to focus on these bottom two equations. And notice here, I don't have to do anything to the top equation. I'm just going to rewrite it. X minus y plus z equals 4. This bottom equation, though, I'm going to multiply everything by -1. So I have a negative x plus 4y plus 5z equals a positive 14. And when I go to add them together, again the x's go away, so 4 minus 1, I have 3y plus 6z equals 18. And here's a really good trick that you want to keep track of. If you notice that there's a common multiple everywhere, I'm going to simplify this by dividing everything by 3. And so what this will turn into is y plus 2z equals 6. Alright, so I have two equations here. I have this equation in y and z, and I have this equation, and I want to bring them together. So it looks like if I multiply one of them by a negative, I can get my y's to cancel. So I'm going to rewrite this one over here, but we're going to multiply everything by a -1. So I have a negative y minus 2z. Actually, I'm going to get rid of this circle. Well, it's okay. Equals a -6. And so when I add those together, notice the y's go away. So now I have z minus 2z. So I have a minus z equals a -3. And now I'm ready to actually solve this puppy. So there is my first solution. So we'll keep track of our solutions down here. We're going to need an x equals, we're going to need a y equals, and now we need a z equals, but we know what z is. Once you get that first solution, everything else is just going to be back substitution. So it's going to be really friendly from here on out. It's just a matter of getting that first variable. Remember, we had to do a 2 by 2 and another 2 by 2 in the same variable. So I can use any equation I want. So I'm going to look at this y plus z is 3, but now since we know that z is 3, can substitute it in. So obviously here y is going to be 0. That was nice. And so I know y, I know z, I can go anywhere. I'm actually going to go to this equation. So I have x minus 0 plus 3 equals 4. So obviously x is going to equal 1. And we have just solved our first 3 by 3. Okay, sometimes when you're solving a 3 by 3, you don't see an x, a y, and a z in all the equations, so it seems like they have all these random different equations. But the concept is still basically the same. We need two equations in two unknowns. So what I'm going to first do is I am going to take this first term and I'm going to isolate one of the variables. So x equals 12 minus 2y. So my goal is I want to use this second equation that has a y and a z, and I want to use this third equation and I want to get rid of the x so that I just have y and z. So I'm using the first equation to isolate the x so I can get rid of it in the third equation. So now this third equation, I have a new name for x, is going to read, instead of x, it's going to start off with 12 minus 2y, and then it's going to have plus 6y plus z equals 20, and I'm going to go through and combine some like terms. So 6y minus 2y, that's going to give me 4y plus z equals, subtract 12 from both sides, gives me 8. That's lovely. Notice now I can bring down this other equation that I have right here. This is my 3y minus 4z equals 25. And I want to make a linear combination out of those. So what I'm going to do is I'm going to multiply everything up here by 4 so that I can eliminate my z's. So I end up with 16y plus 4z equals 32. Downstairs I leave it as it is, minus 4z equals 25. And when you do your linear combination, so I'm going to have 19y, those will go away, equals 57. So we get our first variable, which is y equals 3. And so from now on, it's going to be just a matter of back substituting. So let's keep track. We have our x equals we're looking for. We now know y equals 3. And then we're going to have a z equals. So to find our other variable, if I know y equals 3, I can come right up to here actually. And I know that x equals 12 minus 2 times 3, which is 6. So x is going to equal 6. And now to solve for z, I have lots of options. I am going to go to my 4y plus z equation. Wherever I see a y and a z or xyz, really you have lots of choices here. I could come down here. I know that x is 6. I know that 6 times 3, my new y is 18, plus z equals 20. So that's 24 plus z equals 20. So z is actually going to be a negative number. And there you have solved it. So it's a little different. When you only have the two variables in one of the equations, you could use substitution so that you create a equation that only has the two variables. And then so I know since y and z was here, I knew I wanted to get rid of my x so that I would just have y and z. Okay, quickly for the word problem, let's set it up. We have the sum of three numbers, so we're going to let those numbers be x, y, z. So we're looking for x, y, z. So x will be our first, y our second, z our third. So the sum of the three numbers, x, y, z, is 6. The third number, that's going to be our z, is the sum of the first and second, so it's x plus y. And then we have the first number, which is our x, is 1 more than, so 1 plus the third number. That's our z. Find the numbers. Alright, so let's take a look at what we can do here. I got some potential substitutions I can do. So much we could do. I could change, actually I'm going to make this really easy. If z is the same thing as x plus y, and I have x plus y right here, I can substitute. So that becomes a z plus z equals 6. So I can solve right away that 2z equals 6, so I know that z is going to be 3. Boom, that was nice. Okay, well if z is 3, 1 plus 3 is 4. So I know that x is going to be 4. And I know the sum of those three have to be 6. So I know that 4 plus y plus 3 has to be 6. So y is going to have to be a negative 1. All right, that was your first foray. I would like you guys to try number 9, which actually is a very easy. You'll find your first variable very quickly and then just practice back substituting. And try number 11, at least write it out, and we will continue with this in class tomorrow.